Hello, my dear students, and welcome to a quick uh, little answer to some student questions that I've had. I want to go into a little detail that includes information from various sources and later in the course, and the true correct answer to a question on your homework. I had the question, and that is how. Well, first of all, welcome to my kitchen. This is me. Here's me face. And uh, if it so happens, excuse the sound of the whirring fan and air conditioner in the background, as well as my family, kids and dogs. I did ask them to turn the TV off for this brief announcement or little question response. So, if I may, the question that I had was, if I can get to the homework assignment, was how do you tell an ionic compound from a covalent compound? And basically, we classify compounds as ionic if they have ionic bonds, and covalent if they have covalent bonds. So the long answer has to do with a property called electronegativity, if I may, and that is a property of an atom that defines an atom's property to attract electrons, basically to its nucleus. But there are many uh, periodic properties that we find in the periodic table, and electronegativity is one of them. These are properties that you can make predictions about based on an element's position in the periodic table, and electronegativity is one of them. Uh, right now, you don't need to worry that electronegativity values decrease from top to bottom and decrease right to left or increase from left to right across a period, but it defines how electron withdrawing an element is. In other words, whether or not it will withdraw elements from another atom. And that trend, if you will, that property is determined by many factors, but mainly the number of protons and number of electrons and the electronic structure of an atom, which, as you know, in the periodic table, the atoms are grouped by order of increasing atomic number. And in general, things like atomic mass increases as you get more protons and more electrons, though not always. And those uh, properties of the elements naturally fall into similar groups that we call groups or families, or the up and down rows in the periodic table. So if I may find number 2, rather than remember that electronegativity increases left to right or or increases bottom to top, one thing I always just tell students is just remember fluorine is the most electronegative atom there is. You can see it has a value of 4 for its electronegativity, and all other atoms, well, all other elements, the closer they are to fluorine, the higher their electronegativity. And as you get away, whether you go up and down or left and right, the further you get away from fluorine, the less electronegative you are. If I may quickly show you this more graphically, This is what we usually ask students to remember when we teach this, but it gets confusing because different properties show different kinds of trends, increasing or decreasing, left to right, right to left, top to bottom, bottom to top. And you can keep these arrows and, for example, just change the word increase to decrease. Or you can keep this arrow and change the word decrease to increase, or you can flip the arrow upside down so it points upward and change the word to increase. It if you don't understand more of the underlying principles, it can get tedious to have to remember a variety of periodic trends, such as size, ionic size, ionization energy, and in this case, electronegativity. But I just wanted to define electronegativity, and if I may show you more graphically that electronegativity, here is a uh, graphic, basically a three-dimensional bar chart for electronegativity of the elements. You can see the noble gases have very low electronegativity, and as a consequence, they don't form ionic or covalent bonds. But one way you can tell, and here you see fluorine, of course, the most electronegative, oxygen and chlorine after that, and you see uh, increase in electronegativity, of course, bottom to top and left to right. So when we talk about electronegativity, then we have uh, its role in defining bonds and what kind of bond we're dealing with, and the way the I guess the proper way to determine if an compound is ionic. The simple answer is if it has ionic bonds. Well, how do you tell if a bond is ionic? You look at the bond between the two atoms, and if the difference in electronegativity is very large, then it's an ionic bond. If the difference in electronegativity is very small, then it is a covalent bond. And if it's in between, it's what we call a polar covalent bond. And that's because these bonds, covalent bonds and ionic bonds, aren't just one or the other. Bonds in compounds form a spectrum from purely covalent to mostly covalent but a little ionic, to mostly ionic properties but a little covalent, to purely ionic. And that's measured by the difference in electronegativity between those two atoms. For example, you saw um, fluorine with electronegativity of 4 and hydrogen with an electronegativity of 2. That would be a difference of 2. 4 minus 2 is 2. And if I go to my definition, people make these cutoffs at different spaces. I learned 0.5 or less. Some people say between maybe 0.4 and 1.5, 1.7. But the point is the same. The more electronegativity difference, the more difference, the greater the difference in the electronegativity, if I can get out of this one, the more ionic the character of the bond. So, in strictest terms, if I can find my next little chart, and then I will simplify this, if the difference in electronegativity between two atoms is 0.4 or less, it is considered a nonpolar, pure covalent bond. If it's between 0.4 or 0.5 to 1.5, 1.8 to 2, it's a polar covalent bond. And if it's greater than 2, it's an ionic bond. But we haven't strictly covered that, so I'm going to reduce this to our current level of understanding and define covalent and ionic compounds this way. Here's your answer. If you have a metal plus a nonmetal, that's an ionic compound. Now, this nonmetal can be a halogen or one of the nonmetals on the right side of the periodic table, or it can be a polyatomic ion. So then it would be an ionic compound, a metal plus a nonmetal, even though there may be covalent bonds within the anion, because the metals always have a positive charge, the nonmetals will have your negative charge, and the result is that we have an ionic compound. To have a covalent compound, those form between two nonmetals or a metalloid and a nonmetal. Also, our book and my notes sometimes refer to these metalloids that have partial nonmetal, partial metal properties and lie along that jagged edge in the periodic table as semimetals. So this is how you answer that question. I would also add that when you go to your assignment to answer this question, and I ask you, is a compound ionic or covalent? If it has only covalent bonds, then it is a covalent compound. If it has even one ionic bond, it is an ionic compound because it ionizes when you put it into water or heat it up to separate the positive and negative charges. You'll also find these answers in a longer answer and a more detailed answer with me standing in front of a chalkboard in the video help session for the homework. That will take more than the few minutes this took to explain that answer because it covers everything, but you can speed through it. And of course, there's always, when I ask you on homework, that is open book, open note, that you can take a question like, is this compound, which by the way, this is zinc phosphate. We don't, even though zinc is a transition metal, we don't need a Roman numeral with it because it always has a charge of +2. But if you want, you can say 6,2 phosphate, Roman numeral 2. But this zinc phosphate, you can just Google zinc phosphate and tell me, is it an ionic or covalent compound? That's a tedious but effective way to see what's ionic, what's covalent, and extract from that what is essential about how to identify an ionic compound. Goodbye now, and I'll see you in the next video. If I can.